Hello class. When you get a beaker of cold water and a beaker of hot water and add cubes of sugar to them, the one in hot water will dissolve faster than the one in cold water, therefore having a higher rate of reaction. Wait, what is rate of reaction? Rate of reaction is the amount of product converted or amount of product formed per unit time of reaction. Good. It simply tells how fast and how slow a reaction can be. Chemical reaction in general proceed at different rates. But how does a chemical reaction occur? Collision theory states that for a reaction to occur, the reacting particles must collide with each other. When reaction occurs, products are formed. Anyway, not all collisions lead to formation of products. For this collision to lead to formation of products, the reacting particles must possess the minimum energy needed for the reaction to occur, known as activation energy, and must be properly oriented or aligned so as to hit each other in the right way. Now, we are looking at factors affecting the rate of chemical reaction. They are 1. Concentration of reactant, temperature of the reaction system, pressure of the reactant, surface area of the reactant, catalyst, and nature of the reactant. These factors affect rate of reaction by affecting the amount of energy the reacting particles possess and number of collisions between the particles. Because increasing either of these factors will increase the rate of reaction by increasing the number of effective collisions. Let's start with concentration. Concentration is the amount of a substance in a given volume of a solution. If the concentration of the reactant is increased, the reacting particles become more crowded, therefore giving a greater chance of the particles colliding, hence increasing the number of collisions between the particles, which leads to increase in the rate of the reaction. You can now say that concentration of a reactant is directly proportional to the rate of reaction, since increasing concentration increases the rate of reaction, and decreasing concentration decreases the rate of reaction. The second factor is temperature. Once a substance is heated, the temperature is increased and the particles move faster, acquiring more average kinetic energy, therefore overcoming the energy barrier known as activation energy. The particles also collide more often, leading to increase in effective collision. Hence, the rate of reaction increases. Therefore, increase in temperature increases the rate of reaction, and decrease in temperature decreases the rate of reaction. The next one is pressure. When pressures of the gaseous particles are increased, the volume decreases. A statement proved by Boyle. So when the volume is decreased and as a result of increase in pressure, the reacting particles have a greater chances of colliding with one another, bringing about increase in number of collisions, therefore increasing the rate of reaction. Next one is surface area. Increase in surface area increases the rate of reaction. Surface area of a reactant is increased by cutting it into smaller pieces or by grinding it to powder. When the surface area is increased, more particles are exposed to other reactants and increasing their number of collisions, hence increasing the rate of reaction. It must be noted that smaller particles have larger surface area, while larger particles have a relative smaller surface area. Catalyst. A catalyst is a substance that alters the rate of a chemical reaction without being used up in the reaction. There is a positive and a negative catalyst. Most chemical reactions that involve a catalyst use a positive catalyst. This catalyst lowers the activation energy, which is the minimum energy required. A reaction that would have taken more time to occur can occur in a faster rate when the energy barrier is overcome or activation energy is reduced. Nature of reactants. This explains the difference in the rate of two different reactions, unlike other factors. So substances react relatively faster than others. This has to do with the fact that during a chemical reaction, bonds are broken and bonds are formed. So nature of a reactant means nature of the bond in the reactant. The bond can be ionic or covalent. Let's look at reactions involving ionic bond in aqueous solution. For example, silver ion reacting with chloride ion gives a faster result to produce a precipitate of silver chloride. This reaction happens very fast. On the other hand, reactions with covalent bond happen significantly lower. Example, the composition of hydrogen peroxide into water and oxygen. Now, most of the reactions that take place in your body are reactions involving covalent bond. Those reactions would happen very slowly, but the presence of enzymes in your body makes those reactions happen very fast. Good. Another point under this nature of reactant is the physical state of reactant. You can say in general, the reactant in liquid and gaseous state react faster than those in solid state. Now, you can tell why the food you chew digests faster than the one you swallowed without chewing it. While most of the solid chemicals used for reaction are in powdered form. While vegetables cook faster when they are sliced. While industrial processes require addition of catalysts, and dilute strong acid might not be as harmful as concentrated strong acid. Now, make a video of yourself for this activity. Provide 2 beakers, label A and B respectively. Place an ice water in beaker A and another water liquid in beaker B. Heat both beakers concurrently and record the time it took each water sample to boil. Identify the sample with the higher rate of reaction and give reason for such observation. Thank you. See you next time.